short, no say. So I'm glad I bet you're glad about that. Literally just doing this small little part right here. We're adding a new piece to the puzzle here for what we're doing. We're going to figure out shapes. So it says, using SF2 from above, how many bonded atoms are attached? So let's do SF2 again real quick, all right? So if I have SF2, there's 6, 14, I have 20 electrons altogether. So I'm going to attach my 2, and there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, so we're looking at that. Using SF2 from above, how many bonded atoms are attached to the central? Now, when I say central atom, I mean this guy right here, the one that is in the center, the one that I had to put in the center. Okay, that's the one I'm talking about here. So how many atoms are attached to that? If you said 2, you are correct. How many lone pair of electrons are attached to the central atom? Well, the central atom is right here. Lone pair of electrons mean electrons that are not attached to another atom. So in this case, there are 2. So then what would the shape of SF2 be? So I'm going to, and then it says to draw below. So I'm going to show you a paper, which you guys have probably already seen. It's attached to this. But I want to explain what's going on. So lone pair of electrons, they tend to not want to be around anybody else. They sit on top, they're a little bit heavier, they sit on top and they push down on everybody because of this negative charge. So they're trying to push away from each other, they're pushing down on everybody else. So what you get is you get these 2 lone pair that kind of go to the top of the atom, but remember, they don't really like each other because they're both negative. So they're pushing away from each other, but they're also pushing these fluorines away. So it looks something like that. But now, you guys don't, I will keep saying this and I'll keep being like, why is the shape doing that? Why is it doing that? Well, it's because the electrons are pushing, because they're all negative and they're trying to push away from each other. So let's look at this. Let me go back. Where are you guys at? Oh, you are definitely not biology. I'm sorry. So let me go to this assignment. The notes. And right here. So I have 2 bonded and 2 lone pair is what we said. So altogether that's 4, right? So altogether I have 4 electron groups. Now I don't normally even look at that number. Let me scroll this down a little bit here. Okay, I normally do not look at this number. All I care is that I have 2 bonded and 2 lone pairs. So as I look down here, I'm like, oh, 2 and 2. That's what I look at, but that's what that 4 means, that there's 4 altogether. And that is going to be a tetrahedral. Okay, it's going to be tetrahedral because of the 4. That's why it's considered tetrahedral. But then look at the molecular. This is the electron. We want the molecular geometry. What are these molecules doing? And if you look down here, it is bent. It is going to look like that. What did I do here? Did I just move everything down? I'm going to have to fix it. I'll fix it later. Anyways, this is bent. So what I was just showing you on here, how it bent these down, is because of those electrons sitting on top. So it's bent, and it would look like this. Now, you don't have to put those electrons on top, but you'll see me out, like I tend to put them there, just so people know that's why it's bent. All right, so let's do some examples here. We've got beryllium, and if you look at beryllium up here on the board, beryllium has 2 valence electrons, and you have Cl2, and that is 7 valence, but there's 14. So 14, 16 electrons altogether. All right, so we've got 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16. So I'm going to take from a happy and share. I'm going to take from a happy, stable, and share. So right now, if I look at my central atom right here, I am 2 bonded. And look at this, I have 0 lone pair. So there is no electrons to push these things down. So if there's no electrons to push them down, guess what? It's not going to be bent. So let's go back here. So I have 2 bonded groups, 0 lone pairs. It is linear. Remember, I'm always looking at this one. It's linear. Right? So when you draw this, it would just be like that. All right, let's do the next example. We have boron. So if you find boron on your periodic table, you see that it has 3 valence electrons. Fluorine has 7 valence electrons, but there are 3 of them, so that would be 21. So altogether, there are 24 electrons. All right, now let's put my boron here. I'm going to attach my 3 fluorines. Now, it doesn't matter where you attach them as long as it's around the boron. So there's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I'm going to have to take from a stable and share. So I have, look at your boron here, look at this. I have 3 attached atoms and 0 lone pairs. So 3 and 0 right here. That is trigonal planar, and it's going to look like this. Now this is different than the trigonal pyramidal. I'll show you here, and I'll draw it here. All right, so the planar is going to be like this. These fluorines don't have electrons to push down on them, so they're all going to be evenly spaced apart, kind of like this. Now a trigonal planar, if this were planar, or not planar, sorry, we just did planar. If this were pyramidal, this dotted line means that it's kind of back at an angle, and I would have these electrons that sit on top. So once again, I know you guys might be like, that's crazy, does it really matter? And yes, it does matter in chemistry, so that's why we're doing it. All right, so anyways, that's the only new thing we're learning today. We're now going to do a worksheet, more practice doing your electron dots, these dot diagrams for this stuff, and then once you get those done, figuring out the shape. The next section of notes will add a little bit more to this. So let me know if you're not understanding, because you're going to have to, like, it just keeps adding. We don't get out of this at all. So it's not like we get into a new section and we don't have to do it anymore. So let me know if you need anything, all right? Have a great rest of your day, and I'll talk to you guys later. Bye.